nanomaterials and what are the applications of nanomaterials. So these are the things we are going to discuss in this session. So I welcome all of you to this session. First, understand the word nano. What is meant by nano? You are all very familiar with the scales. Hello Kumar, can you tell me what is micro scale? Selva or Rishwin? Rishwin, can you tell me what is micro scale? Rishwin, Selva, can you hear my voice? Okay, so microscale means 10 power minus 6 and milliscale means 10 power minus 3. These are all you know very well, and nano in the sense 10 power minus 9 meter. So any material which has the size between 1 to 100 nanometer, right? That material is called a nanomaterial. So any material with the size 1 to 100 nanometer is called as a nanomaterial. Okay, clear? Right. So in this set, who discovered this concept nano, and from which it is derived? The word nano. It is derived from Greek actually, and it is coined by Richard Feynman in the year 1959. You may think that it is started discussing since 1959, but now only we start to use this term in all the field. Of course, it is not a very one particular field. It is an interdisciplinary field. It is if you go for biology, if there you can see this miniature of science, science of miniature, physics, chemistry. So it is a field of interdisciplinary field. Understand that one. So in future, definitely this will dominate the entire engineering and technology also. Okay. So in this screen you are seeing some things which are natural and things which are made by human being, right? In this you can see, they say for just example, if you talk about the DNA, DNA size is about 2 to 12 nanometer diameter. It is a natural one, and here if you see the carbon nano tubes, it is about 1 to 3 nanometer, right? So for comparison, you can see there are nanomaterials or materials in smaller size or exist in the world by nature, and we can also make things by some process. So this is about nanomaterials, comparison of man-made and natural things. Then this is about this slide. You can see DNA and bacteria and raindrop and single-walled carbon nanotube, standard strand of hair, house. Just to understand what is nano, I'm showing this slide. Okay, and comparing the size, you can compare a mountain with a child and an ant, then from ant to bacteria and a sugar molecule. You can see these are all. If you think about a sugar molecule, it is in the size of nanometer, 1 nanometer. Size of ant is about 1 millimeter, and the child is 1 meter. And you can see the comparison, right? The size. Okay. Now, nanometers are classified based on the structure. If it is 3 dimension, they are simply called as nanoparticles. If it is 2 dimension, they are simply called as nanowires or nanotubes. And if it is 1 dimension, that is called thin flames. And 0 dimension is called as a quantum dot. So in that small size, it is possible to make the materials in 3 dimension, 2 dimension, and 1 dimension and 0 dimension. Of course, all these 4 materials are playing vital role in engineering technology. Okay. Then, just for understanding quantum dot, so you can see the bulk semiconductor material on the screen, and when you reduce the size into nano, quantum dot structure, you can see the arrangement of atoms is completely changed. Arrangement of atoms, the viewpoint is completely changed. So quantum dot in the sense 0 dimensional material in which the particles are allowed to move, not allowed to move in X, Y, Z direction. So all the 3 directions are restricted. So confinement in this quantum dot is 3. Okay. And this is about the thin film. Actually, this picture was taken during the synthesis of the thin film. Okay, so 2-dimensional, 1-dimensional material, and nano wires, typical nano wire and the nano tubes actually. So it is about 2-dimensional. Here, the particles are allowed to move in 2 directions. Only 1 direction is confined there. That direction is not allowed to move. So, for example, if we consider X, Y, Z, in X and Y, if the particles are allowed to move in the sense, the rest of the direction, the particle cannot move. That means in Z direction, the particle cannot move. So, nanoparticle, come to nanoparticle. First, nano clusters. So, nanoparticles are made by the nano clusters. So, there is group of nano materials that is called a nano cluster. The nano crystal. So, it is possible to make the crystals also in nano size. So, for example, in polycrystalline material, if you make the bulk material into powder, in that case, there is a possibility of getting nano crystals. And the nano colloid and the nano powder you are seeing on the screen. And now, very, very important point, why this nanomaterial is very, very special. I mean, why it is very useful in all this field. We can store more data, and we can use this material for carrying the medicine in the human parts and the human body, and delivering drugs delivery, and for making the strength materials, or mechanically strength materials. So why this nanomaterials are special? First point you should understand, when we reduce the size from bulk to nano, surface area to volume ratio increases. So for surface area to volume ratio increases. That is why this nanomaterial is very special. And it has the quantum confinement effect. I pointed out, if it is quantum dot, if you make a quantum dot that is 0-dimensional nanomaterial, understand, if any particle are placed in that quantum dot, that particle cannot move in X direction, Y direction, and Z direction. So there is a confinement. And if you take a nanowire, particle can move in 2 directions, X and Y, but it is confined in 1 direction. So this kind of confinement effects you can see in the nanomaterials. So these are the 2 important property you can see in the materials when it is nano size. Okay. Then come to this surface area to volume ratio. The formula for surface area, it is 4 pi r squared. Volume, particle in the sense, it is we assume that particles are in the shape of spherical shape. So the volume of particle is about 4 by 3 pi r cube. So surface area to volume ratio, if you calculate, it becomes 3 by r. So once the r value is very, very less, then think about this ratio between surface area to volume. That is 3 by r becomes very large. That is why this material has higher value of the surface area to volume ratio. And one more point, you should understand that they are chemically reactive. Why they are chemically reactive? Due to this increase in surface area to volume ratio. And quantum confinement, just now I explained the quantum confinement there. Okay, and now we will see what are the properties of this nanomaterial. So first we will see order the properties. First physical property, then we'll see chemical, followed by electrical, followed by optical, magnetic, and then mechanical property. Then first physical property. In this graph, it is the graph between interatomic distance and size of material in diameter actually. So you can see this is the diagram which is represented for copper nanomaterials. Okay, you can see initially when the size is very high, you can see interatomic distance is constant. So when you reduce the size into nano, so interatomic distances start to decrease. Okay, so this is the important point you are observing in physical property. That is, interatomic spacing decreases with the size. Okay, then melting point decreases with the size. Second change. First point, interatomic distances decreases with the size. Second point, melting point decreases with the size. Okay, and so this graph shows how the melting point decreases with the size. Okay, and third physical property change you are seeing is smaller the size, higher the ionization potential. So ionization potential, you know what is ionization potential? The potential required to ionize the material. So when you reduce the size, this ionization potential becomes large. Okay, so this graph you can see electron binding energy and relative reactivity, so for nano clusters. And next property is chemical property. So you know that it has large surface area, so it is chemically reactive. Then it can be used as a catalyst, and the nanocluster has strong effects on catalytic property. So to increase the speed of reaction, or to control the reaction, or to modify the things, for all those things we can see in this nanoscale. And electrical property, it can hold more energy than conventional material. Suppose the conductivity is very less in bulk scale. If you reduce the size into nano, then you can see you can increase the conductivity of that material. And optical absorption band can be reduced, or even we can alter by passage of current through these materials. So this point is very, very important. Absorption band can be introduced if it is not there, or if it is there, it can be altered by allowing current through this material. Optical property, depending upon the particle size. So this is the first change you are seeing. When you reduce the size from bulk to nano, you can see color changes in this material. Okay, color changes in the material. That is the important part. So suppose if you take the material in bulk, say for example, if we consider this gold material, suppose you take gold in bulk size, you know the color of gold. You are all very well about the color of gold, but when you start to reduce the size of this gold, what happens? Before 10 power minus 9 meter, there is no change in color at all. But when it becomes equal to 10 power minus 9, you can see there is a lot of changes in color. Immediate change if you are observing in the material in the sense it is first change is about the color. So color of the material will change. Optical properties completely change. That you can see visually. That is the important point you can understand. Okay. Then magnetic property. And of course, since the atoms which are present surface have less coordination number, so it has local magnetic moment. So when it is very close to one another, then there is a chance for losing of magnetic or combined magnetic field also you can see. But when it is have less coordination number in the sense, every atom can possess a local magnetic moment, and a large magnetic moment can also be exhibited spontaneous magnetization at a smaller size. Okay, and antiferromagnetic materials layer, those layers can have this GaN magnetic resistance effect also. So this is about magnetic property. Then mechanical property. I already pointed out that is chemically reactive and interatomic distance melting point decreases with the size. Mechanical property, when you reduce the size, this mechanical property changes a lot. That is, it lower elastic moduli than for conventional grain size material, and 2 to 7 times higher hardness and strength than the large grain size materials. So decreasing hardness with the decreasing grain size in nanoscale, and high abrasion resistance. So these are the changes in the mechanical property of the nanomaterial. So we are discussed about what is nanomaterial and what are the properties of nanomaterial, starting from physical, chemical, electrical, and magnetic and mechanical property. Okay.